Welcome back, everyone. My name is Sarah. I had a fantastic Saturday off, but today is Sunday, which means it's time to come back to work. In order to understand biology, you have to have a basic knowledge of chemistry. So in this video, I'm going to be doing a very brief introduction to some of the fundamental concepts you're going to need to know. I can't explain everything that you need to know about chemistry because I'm doing biology tutorials right now, but I will try to cover the most important things that you're going to need to know. But let's get started. These are some definitions you're going to need to know and understand. We start off with elements. Elements are a substance consisting of one or more of the same type of atom. An example of an element would be hydrogen or oxygen, sulfur, iron. I believe there are 112 elements total. Atoms are the smallest particle into which an element can be divided. And atoms can be further subdivided into subatomic particles. There are many different types. We're just going to focus on three because these are the only ones you really need to know. You have protons, neutrons, and electrons. Protons and neutrons are located inside the nucleus or the center of an atom. Protons have a charge of +1, neutrons have no charge. Electrons are located outside the nucleus, orbiting around the nucleus, and they have a charge of -1. Atoms can come together to form what are called molecules. Molecules consist of two or more atoms. These atoms can be the same type of element or they can be different elements. An example of a molecule would be water, hydrochloric acid, chlorine, molecular chlorine. A list of elements and all of their properties can be found on what is called the periodic table. Elements are going to be arranged by their mass numbers, and there are a couple of properties of the periodic table. We start off with the periodic law. Properties of elements are periodic functions of their atomic numbers, and I'll explain this in the next slide. You have the horizontal rows, which are called periods, and the columns are called groups or families. Periods begin with an element that has one valence electron and ends with a non-reactive element, and elements in the same family have similar chemical properties. I was about to say simical. That's not even a word. When you look at a periodic table, you're going to see the elemental symbol, the atomic number, which is the number of protons, and the mass number. The atomic number is normally in the top left, the elemental symbol is going to be in the middle, and the mass number right here is going to be at the bottom. The atomic number is going to define the element. An element is defined by the number of protons it has. If you change the number of protons, you change the element. If you have the number of protons, you can find the number of electrons. Atoms with no charge have the same number of electrons and protons. The mass number is the number of protons and neutrons in an atom. And since you are given the number of protons, you can always find the number of neutrons by using the mass number. And the atomic mass number is an average mass of all naturally occurring isotopes. Isotopes are atoms of the same element that have a different number of neutrons. And here is an example of an isotope. What I've written here is called chemical shorthand. The top number is going to be your atomic weight. The bottom number is going to be your atomic number. Most people are going to leave the atomic number off since you have the elemental symbol right here. You already know how many protons you're going to have. But anyways, the symbol C stands for carbon. Carbon has 6 protons. And since the number of protons can't change without changing the elements, the number of neutrons has to change. For example, carbon-12, it's going to have 6 protons and 6 neutrons. But carbon-13 has 1 extra neutron. It's still going to have 6 protons, but instead of 6 neutrons, it's going to have 7 neutrons. This is the basic anatomy of an atom. You've got the nucleus, which houses protons and neutrons. You've got energy shells, or electron shells, energy levels, orbiting the nucleus. And then you've got electrons, which are located on these energy levels that are orbiting the nucleus. The first energy level can hold 2 electrons. The second energy level can hold 8. For all intents and purposes, we are going to say that all other energy levels can hold 8 electrons. This is not exactly true, but don't worry about it. Atoms want their electron shells to be completely full or completely empty. This means they want 2 in the first level or none in the first level. They're going to want 8 in the second level or none in the second level. Valence electrons are electrons that are available to form chemical bonds. Atoms with a full valence shell are not reactive. For example, helium has 2 electrons in its first shell, no electrons in any other shell. Helium is not a chemically reactive atom.